Okay, so in this video, I'm going to recap how to write an ionic formula. Now, we did this back in year 10, okay, and we also did some practice on this earlier in the week. However, some people seem to be a little bit confused by it, didn't remember it very well, so I'm going to break it down here. Okay, so the first thing that we need to know when we're writing an ionic formula is the positive ions and the negative ions in that formula. Remember that the positive ions are either metal ions or the hydrogen ion, whereas the negative ones are the non-metals. And there are predictable patterns. All the metals which are in group 1 have got a charge of +1. All the metals that are in group 2 have got a charge of +2 when they're ions, and all the metal ions in group 3 are going to have a charge of +3. As well as that, there are some other ions, the transition metals, which don't have a set value. Those would be given to you in the question. So you might have iron can be a 2+ or it can be a 3+ ion. Copper, usually 2+, but not always. Nickel, and so on. These are all relatively common ones that you might see. They'd usually be given to you in the question. You're not expected to remember them. For the non-metal ions, we've got things like chlorine. It's in group 7, and its ion, the chloride ion, is -1. So are all of the other group 7 ones. They're all going to be -1. The ones which are in group 6 will be -2. And the ones that are in group 5 will be -3. There are also some examples of complex ions. For example, the sulfate ion, SO4, has got a charge of -2. The carbonate ion, CO3, has got a charge of -2. And the nitrate ion, NO3, has got a charge of -1. Now, these 4, it is very, very important that you learn these. I did tell you this back in year 10, because these will not be given to you in the question. You are expected to remember them. Okay, so when we get the name of a compound, for example, magnesium chloride, in order to write the formula of magnesium chloride, we have to think about the charges of its ions. Okay. So the magnesium part, magnesium is in group 2 of your periodic table, and therefore it's going to have a charge of +2. The chloride part, it's in group 7, and therefore it's going to have a charge of -1 when it's in a compound. So I'm not saying that magnesium metal has a charge of +2. When it's an element and it's on its own, it doesn't have a charge. It's got a charge of 0. But when it's part of a compound, like magnesium chloride, and you've got 2 bits, then it is going to have a charge, and that charge is going to be +2. Now, in order for me to make this compound, my charges have to balance. They have to add up altogether to 0. And as we know, if you take +2 -1, you are not going to get 0. You're going to get +1. So at the moment, this doesn't work. So in order to make it work, I need to have 2 of my chloride ions, because +2 and -2 twice is going to equal 0. Okay, so +2 plus -1 twice is going to be -2. They'll be equal. So the formula will be MgCl2 because I need 2 chloride ions to balance the charge from my magnesium ion. Let's do another one. So if we do sodium oxide as an example. Okay, again, sodium is in group 1, and so it's going to have a charge of +1. Oxygen is in group 6, and so the oxide ion will have a charge of -2. Okay. I've got to get them to add up to 0. This time, I don't have enough positives to balance the 2- from my oxygen, so I'm going to need 2 of my sodium ions this time. So the formula is going to be Na2, 2 sodiums, and 1 oxygen. Now notice I've not put any charges in here. So here and here, I haven't put any minuses or any pluses because they've cancelled out. That was the whole point of me having 2 chlorines, is that those charges cancel and I don't need to write them in my formula. Let's try a couple of trickier ones. Okay, let's do aluminium oxide. Okay, so aluminium is +3 and oxygen is -2. Now this time, I can't just multiply one of them, because if I multiply -2 by 2, I get -4. That still doesn't balance and add up to 0. So if you get into this situation, you need to look for the lowest common multiple. And in this case, the lowest common multiple between 3 and 2 is 6. So I need to make the aluminiums add up to +6 and the oxygens add up to -6. The way to do that is times my aluminium by 2 and times my oxygen by 3. So I will have Al2O3, and that will be my formula. You can do exactly the same thing with the complex ions. Okay. So if I have, for example, potassium sulfate, potassium is +1, sulfate, SO4, is -2. So I'm going to need 2 potassiums to balance the charge from my sulfate and make them both equal to 2+ and 2- so that they cancel. So my formula will be K2SO4. One more example. These are the trickiest ones. Okay, when you get something like copper nitrate, copper +2 and nitrate is -1. So this time it's the nitrate that I need 2 of. Okay, now if I write it like this, that could potentially be confusing because it looks like I've written 1 copper, 1 nitrogen, and 32 oxygens because of the way it's spaced out. So if you get a complex ion, one of these highlighted 3, these are called complex ions because they've got more than one element in them. The complex ions have to be in brackets so that you can show that everything in the brackets is times by 2. Okay, that's the basis of how to write ionic formulae. Okay, so you should now be ready to go and try and do this for the reactions described in task 2. Have a go. If you've got questions, things you don't understand, you can send them to me via the chat on Google Classroom.